So now if we talk about the second problem, so it is like called nearest point function. So I'm just talking about the Kotlin Heroes episode 7 B problem. Okay, so I will like quickly read out the problem statement so that the problem becomes more clear. Okay, so basically what the problem statement says is that we have like a nearest point function. Okay, so what it does, so basically if we are given an array of integer x which is sorted in ascending order without any duplicates and a point y, okay, so it can find the nearest point from x to the point y. In other words, it will find such a value xi that mod of y minus xi is the minimum possible. Okay, now here is the catch: mod of y minus xi. So let me write it here. Mod of y minus xi. Now the thing is that without proceeding any further, I just want to make clear is that this mod function will give like equal values for two xi's. Okay, if y is constant or y is like constant, it will give equal value for two xi's because it is mod. So if even if the answer comes positive, the ultimate result will be positive of the same magnitude, and if the answer comes out to be negative of the same magnitude, so ultimate result will again be positive. Okay, and if the magnitude is same, so I'm just saying that this function would give or can give two equal values. So this thing that you need to take care in your mind. Okay, now if we proceed, there is an example which is given. Okay, so x is an array of obviously sorted in ascending order without any duplicates. So 1 2 5 7 9 11 are the elements, and there is a y equals to 3 given. Okay, so like if we try to find the what will the result of the function, so it will be 2 because if y is equal to 3, then it will obviously take 2 because y minus 2 becomes 1, and it is the minimum possible values from that given array. So the result will be 2, and if y is 5, then the result will be 5 because 5 minus 5 is the 0, and it is the minimum possible value that we can find from this array. Okay, and if the y is 100, then the answer would be 11. Okay, because obviously y minus 11 would be mod of y minus 11 would be the minimum possible values. Okay, when y is 100. Okay, so it was just the problem statement. Now the main thing comes, that is this function is a bit buggy though. If there are several nearest point to the given one, now what is the nearest point that it is just an answer. Okay, it is just the output of the function. Okay, so that if y was 3, then nearest point was 2, like that. Okay, so it's just saying if there are several nearest point. Now there could be several nearest point. Why? I just showed you, I just like had this example that if it is mod, then it will give like for two different xi's or two different x, it may give the same result because magnitude ultimate becomes positive or sign ultimate becomes positive, and if magnitude is the same, then the result will be same for two values. Okay, so that's what it's saying, that if there are several nearest points to the given one, okay, the function crashes. For example, if x equals to 1 2 5 7 9 11, so if I try to copy it, can I paste it here? Yes. So like if x is 1 2 5 7 9 11, and if we choose y equals to 6. Now there could be two nearest point. How? It will be this 5. Okay, so this will be, it will be this yeah, yes, this 5, and also this 7. Okay, how? Let me show you. If I just said 6, where y is here 6, and 6 minus 5, mod of 6 minus 5 would give 1, and mod of 6 minus 7 again give us 1. So that's what there could be several nearest point values. Okay, so that's what it's saying. If y is equals to 6, the function crashes, because since 5 and 7 both are nearest points for 6, where 6 is our y. Okay, so our task is that for a given array of integer point x, which is sorted in ascending order without any duplicates, determine if it is possible to cause the function to crash by choosing some integer point y. Now it's upon us that we can choose any y, and we have to say whether we can cause it crash, and when it will crash, when we have two nearest point values or several nearest point values for a single y, so then it will get crashed. Okay, so now we have to just find out whether we can crash the function or not for a given array. Okay, if we could find a value of y or not. So the inputs are as follows: the t test cases, n is the like number of points in the array x. Okay, so elements basically, and the like magnitude of the elements, or the elements basically, and yeah, like that. And we have to output yes if it is possible to crash, or no if it is not. So now, like, the thing is, how would I know whether it is possible or not? Okay, so like, if you, now again I'm taking this mod value. So basically this is mod of y minus xi. Okay, and now if we like remove the mod, what this value becomes? Well, it will give us plus minus. So if I could write it here, yeah, plus minus, it will be both plus minus y minus xi. Okay, again y minus xi. So if we remove the mod, we will have to add a plus as well as a negative also, because we are removing the mod. And mod, what mod does, it like converts all the values to positive, whether it is positive or it is negative. So we have to consider both the signs. Okay, if we remove the mod, it is basic maths, nothing else. Okay, so like that. And now if we kind of make this a function that y minus xi equals to negative of y minus xi, because I'm saying that we have to find a y so that these two value becomes equal. So I'm just doing only that. So basically it is nothing but it is the positive value, and this is the negative value. Okay, so I'm just doing that, and we have to find out a y, so that there is like, we have to find out a y so that the function crashes. Okay, so now we if we solve this equation, so y minus xi is equal to minus y plus xi. Okay, and now if we get the y on the left hand side, so 2y becomes like 2y becomes x. Okay, so what we have to do, we have to find 2. Okay, so what I'm just a silly mistake in here is that, so we won't take both of where I, but one xi and another where xj. So basically we have to find two x's now. That's why we are taking these two xi and xj. They are two different x's, and we are and in the problem statement it is clear that there is no duplicate value. So now y minus xi minus equals to minus y plus xj. So it becomes 2y equals to xj plus xi. Okay, and now y equals to xj, or basically xi plus xj upon 2. Okay, so now we can say if we could find two x or 2 points in the array, that it which is if so that 2 divides that their sum. So if 2 divides their sum, it means that their sum would be even. Okay, and when two numbers sum becomes even, whether both of them are odd or both of them are even. There's only one way, when there's one option when it is not even, when one of them is odd and one of them is even. So if we could find xi and xj, two values of x's, so that their sum becomes even or their sum becomes odd, so that like, and when they become even, or when they become even, when both of them either even or both of them either odd. Okay, now so we have to find two x's. Now there is one more thing in here. We won't just find any two x's. Like if I take this example, we won't find any two x's but adjacent ones. Okay, and why adjacent one? Because we have to also take care of that we get the minimum nearest value. Okay, so we have to fulfill the function's statement, that nearest point function, and it gives the minimum possible value. Okay, so if we find, like if we take one x from here and one x not taking from adjacent or taking from anywhere else, then then its result, if we sum those x's and divide it by 2, then its result will lie in between them. And if it lies in between them, then it is like no more the y is no more the wanted y for these two values of x's. Okay, so basically we have to find two x's which are adjacent and both of them are either odd or both of them are either even. So like if you take 1 or 2, it won't give the answer. 2 or 5, it will give the answer. Why? Because no, it won't also give the answer, because 2 is even and 5 is odd, so it won't. Now if we take 5 and 7, it will give the answer, because here if I say 5 plus 7 by 2 equals to 6. Okay, so it is 6, and if we like pick 6 y equals to 6, then for y equals to 6, this will give the same result. Now if I take another example just to show you what is going on, so like 1 3 5 8 9 11. Okay, now as I said, we have to find adjacent values of the points in this array, so that either both of them are odd or either both of them are even. And if we could find the value, if we could find such adjacent pairs, then we'll say we can crash the function. Crash the function means we can find a y so that two values of xi gives the same nearest, same that gives the function gives the same answer. Okay, so 1 and 3, will that work? Yes, because 1 is also odd, 3 is also odd, and if we sum these two values, 1 plus 3 by 2 equals to 2. Okay, so if we take y equals to 2, so if we take y equals to 2, so y minus 1 also, mod of y minus 1 also becomes 1, and mod of y minus 3 also becomes 1. So simply this implies that we can make the function crash. So it was just simple, like the end result of my like theory was we have to just find two adjacent values of x, or the elements in the x array, so that whether both of them are odd or both of them are even, so that we could sort of divide it by 2. So that's why I'm saying either both of them should be odd or both of them should be even. And if we are able to find this out, we can simply say we can crash the function, and if not, we cannot crash the function. So if I take an example where we cannot find any value where we can crash the function, so it would be like this. Now in this array we cannot crash the function because we cannot find like any adjacent pair of the elements where the sum becomes even, so we cannot crash the function. So we have to just find this out. Now if I go to my code and show you what I had done, so I have just taken the input, okay, the number of elements in the array, and then I have just read the integer array. Okay, this is like predefined function in my template, read int array, that reads the number. Okay, and I have initialized flag equals to false. Now what this flag does is, if we iterate through all the elements in the array, and if we find such pair that I was talking about, then we will convert our flag to true and break out of the loop. Okay, so that's what I'm doing. So initialize the flag equals to false. Now I'm looping through the all the elements. Okay, so I've in 0 until n minus 1. Why I'm just looping through 0 1 2 like that, not all the elements, because I'm taking like this 1 2 2 5 and 5 8. So that's why I'm leaving one index, okay, in iteration. Okay, so now in each iteration what I'm doing, I'm saying whether if nums I and 1 equals to 0, that means I'm checking either both of them should be even or both of them should be odd. So it is like I'm just taking the AND value, I'm doing and if AND becomes 0, that it is odd, it is even. So that, and also if it is even, and if the next element, if that also even, either this should happen or the first element should be odd, or the next element after that should also be odd. So I'm just checking that out. So either both of them conditions holds true, and just it is, and it is just bitwise operation of checking odd and even. Okay, it's nothing else. We could have done percent or modulo 2 as well. Okay, so if the condition holds true, we'll say flag equals true and we'll just break out of the loop. And at the end, what I'm doing at the end of the function, I'm returning if the flag is yes, that means we have find such y, or if it is not, we have not find the y in the array. So if we have find the y, we'll return yes, and if we have not, we'll simply return no. Okay, so that's what it is doing. And if I could show my code as well, it's just simply like that only. Okay, I've done only that. So if I could zoom the screen, so this is the same that I showed you earlier. Okay, so like this is the solution of the problem. Okay.